Hello everyone. Now this time I will do 2005 AP Calc BC exam. This is Form B in number 4. Form B is also a little bit tricky, so I'll go through number 4 with you, which is a very tricky question. Let's get started. It gives us a function of f and nicely give us all the points. And asking let g be the function given by g of x equals integral of -4 to x f of t dt, and for each of g of -1. So what's g of -1? G of -1 is going to give us -4 to -1 of f of t dt. So what is integral? Integral is the area under the curve. So in this case, it's the area from -4 to -1. And it's a trapezoid. So we'll use the area of a trapezoid. 2 plus 3 times 1/2, which give us 2/15. But wait a minute, this area is below the x-axis, which means that we actually have a negative integral. So the answer is not 15/12, but -15/12. Now let's look at the second one, g prime of -1. According to the second fundamental theorem of calculus, g prime of -1 is the same as f of -1, because g prime of x is just the same as f of x. This is just the second fundamental theorem. If you take the derivative of integral, you just have the function itself times the derivative of x, and the derivative is 1, so basically this is how it looks like. So f of 1 at -1 is -2. So g prime of -1 is -2. Very easy, huh? Now we ask g double prime of -1, which is f prime of -1. But wait a minute, f prime of -1 is right here. So what's this? It has a sharp turn. And according to the derivative definition, at here, the function is not differentiable because you have a sharp turn. So g double prime of -1 does not exist. Interesting, right? Now let's look at B. For the function g defined in part A, find the x-coordinate of each point of inflection on the graph of g. What's the point of inflection? The point of inflection is when g double prime equals 0. That's when you have the point of inflection. We already know that g double prime is f prime. So we need f prime equals 0. And technically speaking, there isn't any point on this graph when f prime equals 0. But what we're really looking for is a point where f prime of x goes from increasing to decreasing. Why is that? Because look at, if this is a graph, this is 0, it goes from increasing to decreasing. Technically speaking, at f equals as f prime of 1, you don't really have a derivative. This does not exist because you have a sharp turn. But since this is the only point where f goes from increasing to decreasing, this is the only point that's available. So the only point that g has a point of inflection is when x equals 1. Now C is asking us, let h be the function given by h of x equals an x to 3f of t dt. Find all value of x in a closed interval for which h of x equals 0. So let's do this out. If h of x is the integral of x to 3 f of t dt, we can write this as negative integral of 3 to x f of t dt. This may not be that much helpful in this question, but it may be a lot in part D. Because since this equals 0, negative 0 is still 0, so it doesn't really matter. So let's look at this. What this is really asking is, if you go from here to the left, 1, well, your summation of area became 0. We know that 3 is obviously the first choice because you don't integrate anything, you have 0. And then you go, this is an x to 3, you go from right to left. Now, the first part is you have this area, which will be all negative. Then you have this area, which will be all positive. Amazingly, these two areas have the same magnitude of area. So the next one is when x equals 1. And then you keep going. You have actual area of this, which is positive, and then have actual area of this, which are negative, which amazingly have the same magnitude too. So you have x equals negative 1. But then if you keep going, this area will all be negative, so we'll never have a positive to balance this out. So the only 3 points when h of x equals 0 is when x equals 3, 1, and negative 1. Now let's look at D. D, find all interval which h is decreasing. We know that h of x equals negative integral of 3 to x f of t dt. According to the second fundamental theorem for calculus, we take the root on both sides. H prime of x will be negative f of x. When h is decreasing, meant f prime of x is smaller than 0. That's when h is decreasing, which meant negative f of x is smaller than 0. Which, if you multiply negative 1 on both sides, f of x is greater than 0, because negative change the sign. Which interval is f of x greater than 0? The interval of 0 to 2. So the answer will be, in the integral of 0 to 2, h of h, the h is decreasing. This question is amazingly, it doesn't really have much calculation, but it's based on a lot of understanding of calculus, and also how the second fundamental theorem calculus and how you look at the integrals as the area. Again, thanks for watching.